Section 5.2, verifying trigonometric identities. These are the objectives. You can pause to read them, but I'm going on to the next slide. This is the key concepts. You should know the fundamental identities. And also this is the big one. Whenever you're verifying identities, work with one side of the identity at a time. And I have talked about this prior to this lesson, just bringing the point home. Work only on one side of the identity. Here we go. This is verify the identity. So we're gonna make one side equal to the other side. So what you want to do, I'm going to work on the complicated side. This side looks more complicated than this side. So this is what I'm going to do. I notice that I have two terms. This is my first term. This is my second term. So I have a binomial on the left hand side. So what I'm going to do is I'm going to look at for the GCF, the greatest common factor of this binomial. It turns out to be secant x to the fourth power secant x tangent x. So once you pull out this GCF, you're left with secant squared here, and you're left with, bring down the sign, and then you're just left with 1. At this point, you're going to notice that all this becomes tangent squared x, because this is a Pythagorean identity. And then at this point, I'm just going to multiply. And notice that this becomes secant to the fifth power, secant to the fourth, secant to the first, tangent squared, tangent to the first, and that's how I end up the left side, which is equal to my right side. So I'm done with number 1. Number 2, I want to make one side equal to the other side. So what I'm going to do is I'm going to work with the left side. Notice that here the cofunction identities should come to mind. If I refer to my cofunction identities formulas, this is what I get. This becomes cosecant of x. This becomes cotangent of x. At this point, this is cosecant of x times 1 over cotangent of x, but 1 over cotangent of x is tangent of x because that's one of the reciprocal identities. At this point, I change everything to sine and cosine. This is what I get. From here, these go away. I end up with this. I know that this is secant of x equal to the right side. Notice that on number 1 and 2, I'm only working on one side, and I'm trying to make that one side that I'm working with equal to the other side. And again, to emphasize this, you always want to work on the most complicated side. Number 3, left side, right side. This looks more complicated, so I'm going to work on the left side. What I'm going to do is I'm going to leave this alone. I'm going to do something here. I know that this, I can rewrite it as sine of y, but in front I put a negative y because sine is an odd function. Then once I do this, I have two binomials. So what I need to do is I need to just FOIL. I end up with this binomial, and then at this point you should be able to recognize the Pythagorean identity. And this becomes cosine squared y, which is equal to my right hand side. Moving on to number 4. Again, left side looks more complicated. So what I'm going to do, I'm going to write this. I know that cosecant is an odd function, so cosecant of a negative angle is just negative cosecant of positive angle. Cosine is an even function, so that's why it becomes just cosine of theta. Cotangent is an odd function, that's why I have negative cotangent of theta. And then at this point, what I'm basically going to pull out a cosine of theta out of this binomial. I know that this is the same thing as cosine of theta over sine of theta. I pull out the cosine and I'm left with this binomial. And then at this point, I notice I leave this alone, the numerator alone, but now I'm going to do something with the actually, I take it back. I'm just going to rewrite this binomial here in the denominator, and I get 1 minus cosecant of theta. At this point, you should be able to see that you have a common factor. So this goes away. I'm left with, let's go up here, 1 over cosine of theta, and I know that this is equal to secant of theta, which is equal to my right-hand side. So I'm done with number 4. 5. This one looks more complicated. And of course, the left side looks more complicated. So I'm going to be working with this side. So this is my hint. This is the big hint in the problem. Do you see this 1? So what I'm going to do, I'm going to look at this left side, and this is related to this. So what I'm going to do is I'm going to try to make this a 1. Why? Because I want to make this left side equal to the right side. How do I make this expression here into a 1? I am going to divide this by cosine of x, cosine of y. But I cannot just divide just this portion of this expression by cosine of x, cosine y. I have to divide every single term that you see here in the binomial, in the numerator, binomial in the denominator. So this is what I get. Cosine of x, cosine of y, cosine of x, cosine of y, divided by cosine of x, cosine of y. And every term that you see here is divided by cosine x, cosine y, cosine x, cosine y, cosine x, cosine y. And then at this point, you should see that this becomes 1. This, excuse me, let me go to this one. This goes away. This goes away. And I'm left with whatever this is, and whatever this is. And the 1 over here. You should be able to follow why this is tangent of x, why this is tangent of y. We know this is 1. Bring down the sign, bring down the plus up here in the numerator. And then this is tangent of x, this is tangent of y. And notice that this equals the right-hand side. So I'm done with number 5. But this is your hint, right here. This gives it away. This guides you what you should be doing, what you should be dividing by. Let's go to number 6. This one's a little more challenging, but it is what it is. I am going to work with the left side. So this is what I do. I want to get rid of the radicals somehow because the right-hand side doesn't have any radicals. So what I'm doing is I'm actually multiplying top and bottom by the conjugate of the denominator. What is the conjugate of the denominator? 1 plus cosine of theta, 1 minus cosine of theta. And you should have seen something like this in algebra 2. You should have. The concept of conjugate should not be an unfamiliar concept. So now what I'm going to do now is just FOIL. When I FOIL in the denominator, this is what I get. In the numerator, I just have this. I'm not going to FOIL. I take it back. Just FOIL in the denominator, but not in the numerator, because this is just 1 minus cosine theta squared. And then at this point, I'm going to rewrite this as sine squared of theta, the bottom portion, because I know that's a Pythagorean identity. And then at this point, this is what I get. The square root of 1 minus cosine of theta squared is equal to just 1 minus cosine. What is the square root of sine squared theta? This. This is just 1 minus cosine of theta without an absolute value. The denominator, you do need an absolute value. Why? talk to me after class. Talk to me in class, and I'll clarify why we need to write absolute value. But it kind of gives it away that this side, the denominator should have an absolute value. So you know you should have an absolute value, but it's good for you to know why we need to write an absolute value here in the denominator and not an absolute value in the numerator. Moving on to number 7. So this one looks different, but you're verifying that this is an identity. So you want to see that one side is equal to the other side. So what I'm going to do is I'm going to work with the left side. I'm going to start by working out with sine inverse of x. I know that this represents an angle, so that's why I let it equal an angle. Definition of inverse function, I know that this is equal to that. And then at this point, I'm going to draw a right triangle. Sine of theta, opposite over hypotenuse. So this is my right triangle, opposite hypotenuse. I can find this by using the Pythagorean theorem, excuse me. This is what I get. Then at this point, this is what I'm going to do. I know that I let this equal to theta. So technically, what I need to do is I need to compute cosine of theta. So what is cosine of theta? I go to this right triangle. Definition of cosine is adjacent over hypotenuse. So 1 minus x squared, square root of that, divided by 1. I simplify this. This is equal to what I wanted to equal. We're done with 7. Let's go to number 8. Number 8 is very similar to number 7. Same process, just different values. So again, this is an angle. I let it equal theta. At this point, I use the definition of inverse. And this is what I get. Cosine of theta is equal to x plus 1 over 2. From here, I draw my right triangle. X plus 1 is cosine is adjacent over hypotenuse. That's why I have x plus 1 here, the 2 here. By using the Pythagorean theorem, I know that this becomes that. And then at this point, again, this is equal to theta. So I'm computing tangent of theta. Tangent of theta, I go to my right triangle. If you look at this, look at that. You're done with this section.